Just to put into perspective, the amount of solar energy that shines upon Earth every day is roughly 173,000 terawatts of solar energy, which is almost 10,000 times the amount of daily energy requirement of Earth. Now, the reason I mention this interesting fact is because it is now more necessary than ever for us to shift our energy dependence from non-renewable energy sources to renewable energy sources. Because in a recent interview on 28 July of 2023, the UN Secretary General mentioned in an alarming note that the days of global warming are over and the days of global boiling are here. Such remark by the UN Secretary General should leave a striking impact on all of us and force us to take an immediate action over it, which no longer is a closed room discussion but an important action point for all of us. With this narrative in mind, I, Rifat bin Sultan, have been conducting active research on the viability of use of cadmium telluride thin film solar cell against silicon for manufacturing thin film solar cells. Now, the reason I propose cadmium telluride as an ideal candidate against silicon because it has an absorption coefficient which is 10 times more than that of silicon. Also, its bandgap value is 1.45 eV, which stands in the ideal bandgap range of 1.4 to 1.6 eV, which is an utmost necessity for a thin film solar cell to give maximum efficiency and maximum output power. Moreover, in order to reduce the material requirement for manufacturing thin film solar cell on a commercial scale, we can use cadmium telluride as an ideal substitute because it can absorb almost 96% of the visible spectrum using only 1 micrometer of dimension, whereas for silicon to do so, it would require almost 200 micrometer of dimension. Under all these points and highlights, we can now understand why cadmium telluride stands as an ideal candidate against silicon. Moreover, my research scope also includes incorporating different nanostructures such as nanogritting on the cadmium telluride thin film solar cell to further enhance its efficiency and electrical performance parameters. For all this research, I am being helped actively by Independent University of Photonics and Simulation Laboratory, or shortly known as IUBPSL. Thank you.